Hi guys, Mo here, your guide for learning more about HAZOP. Before we start today's topic, which is rule number 3 and 4, I just wanted to mention that I've come across with many professionals in high-risk industries who basically feel unsure about how to contribute meaningfully and confidently in a HAZOP meeting, like for example, identifying the nodes and actively participating in the discussions and understanding everything from inside out. So just wanted to mention that if you are a newly promoted manager or an early career engineer or someone who just wants to step confidently into the role of a HAZOP scribe, or a participant who confidently contributes to the meeting, you're exactly where you need to be. This channel's purpose is to actually help and take you from uncertainty to the clarity by giving you the practical, structured, real industry understanding from most uh, examples that I have personally experienced. And this is going to be your practical guide, how to step confidently into this realm. So with this introduction, I would like to introduce the system that we are going to review today. It's a refrigeration system that is using ammonia, and it's a typical refrigeration system cycle. I'm going to walk you through what's happening inside the process. And then as soon as you get a decent handle of what's basically behind the scenes, then it would be no problem for you to mark up the notes. One more thing is that today's discussion is a bit different with what we've done previously, and the reason I'm saying that's a bit different, today we're gonna mark up the notes on the PFDs, which is a bit different, or maybe even much easier compared to P&IDs. P&IDs have got more details. But the good news is that as soon as we understand how to mark the notes on the PFDs, it can be marked on the P&IDs in the same manner. So it's just like you're doing the difficult work on PFDs. As soon as you understand the inlets and outlets of the process there, then it would be much easier for you to mark them on the P&IDs. So, as I explained before, to understand what's happening inside the process of this refrigeration cycle, we need to either go to a document called process description, or to go through the document which is called functional description. So I believe that in case of a refrigeration cycle, mostly the document that you'll come across with would be a functional description, as it's not a complicated system with plenty of P&IDs and PFDs. But anyway, if there's a process description, that's all right as well. The first equipment that we are looking at today is the compressor. So inside this compressor, I have marked two different colors. One is yellow, the other one is dark brown. The yellow is showing the high pressure and temperature ammonia, which is being compressed. And at the bottom of that, I've shown this dark brown color, which is the color of the oil which is used for the lubrication of the compressor is mixed with ammonia in this phase. That's why they're both shown in together. The next equipment we are looking at is the oil separator. Its name is actually the guide. What's the function of this equipment? This equipment actually separates the oil which is used for the lubrication of the compressor from the ammonia gas. Then the high pressure temperature ammonia will leave this vessel from the top of the vessel, and the oil will be actually accumulated at the bottom of this separator. And it's not shown on this PFD, process flow diagram, but this oil will recycle back into the compressor, and either it could be by a pump or it could be just by the suction pressure of the compressor. There are a couple of equipments connected to the oil system, which could be filters, oil cooler, and isolation valves, which are not shown here, and I'm not going to explain about them, but just to give you a bit of a hint that yes, there's a recycle line which is not shown here. Anyway, next equipment, evaporative condenser, which is receiving high pressure temperature ammonia gas into it. Air is passing through it, as you see the fans on top of it, and it turns the high pressure temperature ammonia gas into high pressure temperature liquid ammonia, which is collected at the bottom of the evaporator. Then we are looking into the next equipment, which is high pressure receiver. That high pressure receiver now has got, again, two phases. At the bottom of that, we have high pressure ammonia. Top of it is a bit of a ammonia gas, which basically is connected to the via the balance line to the compressor. So that gas would be recycled back into the compressor. Flooded plate heat exchanger is or subcooler is the next equipment we are looking at. It's got two different sides. One side will be on the left-hand side, if you look into that, will be filled by high pressure ammonia liquid, and then the left-hand side of that will be filled by some liquid which is collected, some ammonia liquid which is collected at the bottom of the high temperature accumulator. I have not shown it yet, but yes, these two fluids are actually there's a heat transfer between them, and the blue liquid is actually losing heat to the green liquid and turns it into a saturated vapor, which would actually be routed into the high temperature accumulator. Then the next equipment, basically you're looking at a pair of valves, which is right downstream of the liquid discharge on the left-hand side of the flooded plate heat exchanger subcooler. Those pair of valves will cause a huge temperature and pressure drop in that liquid line, and it turns that flow into a two-phase flow. At the beginning, the quality of liquid ammonia is higher, but as soon as it gets into the next equipment, which are the evaporators, both of them, the chiller and then the other one, which is the freezer, they change into saturated vapor by absorbing the heat from the air, or from the air which is passing through. And that saturated vapor, which actually could be a bit superheated, will pass through the lines which are connected at the discharge and goes now to the next equipment, which is your high temperature accumulator, and is collected on top of it. So basically, I can say that the whole we can consider from the expansion valves, when we have this huge pressure temperature drop, we are getting a two-phase flow of ammonia, of a cold ammonia right at the beginning with a liquid quality, more liquid quality, and then it gets into the evaporator, evaporates into, again, a two-phase, but here we've got more quality of the vapor phase, which then is routed into the high temperature accumulator. So there we've got a combination of both phases, mostly vapor, and you've got a bit of a liquid at the bottom. And that liquid at the bottom is your rule number 4 that we will discuss about it later. So basically, by looking into the inventories as has been marked on this PFD, I guess the next thing is just use some common sense and connect the dots, and shouldn't be really a difficult task to mark the nodes on this PFD. So node 1, as you see, starts from the compressor to the top of the oil separator and then is routed directly into the inlet of the evaporative condenser. And as you see, the top of the high pressure receiver and the compressor are also connected via a balance line, which transfers any potential existing gas to the suction of the compressor. So that is your node 1, which is easily marked. Then you go to the next node, which is node 2. Is absolutely easy to mark it. It's the brown color oil system, which you can simply mark it because you've got the oil phase there, and it's recycling back into the compressor. So as you see, both compressor and oil separator, they've been divided into 2 different nodes, and you need to consider that. So when you're looking into the hazards, loss of oil or a no flow of oil could cause jamming of the compressor that could actually damage the compressor, and there would be a failure or a seal break or stuff like that. And also for the compressor, if you're looking into the high pressure, then you look into the node 1 and then the blockage of that, which could actually cause problems if there are no controls, and then you have to review that during the HAZOP. So this is your node 1 and node 2. For node 3, the bottom of the evaporative condenser and the liquid which is collected in the high pressure receiver, they're both connected, they're one node, and then the discharge of the from the high pressure receiver goes directly into the flooded plate heat exchanger subcooler, and then passes through that, loses a bit of a temperature, and then it goes to the inlet of the temperature expansion valves. We just keep it there as node number 3. You just need to consider the makeup line also, which is getting into the high temperature accumulator, which is just feeding a little bit of liquid whenever it's required. It's not a continuous flow. So keep that in mind. And then, that's your node number 3. For node number 4, as I said, you're looking to the downstream of expansion valve. That causes a huge temperature and pressure drop. That is why rule number 3 is applicable here. What does rule number 3 say? It's very close to rule number 1, but in rule number 1, we had a change of phase, but here we don't have a change of phase. It's the same liquid which is getting into the temperature expansion valves. The discharge is also a two-phase flow, huge pressure drop, huge temperature drop. That's why you need to change the node here from node 3 to node 4. So downstream expansion valve, you're having a two-phase flow where the high quality of liquid gets into the evaporators, both for the chiller and for the freezer, depending to the amount of the temperature drop. And then it absorbs the heat from the air, and then it leaves the evaporators in form of a saturated vapor, or maybe even a little bit superheated. And in that two-phase flow, it goes back to the top of the high temperature accumulator. So that high temperature accumulator has got two phases inside. I'm not going to say how much of liquid and gas, or how much of liquid and vapor, but the point is that right at the bottom, we've got a little bit of liquid, which is coming and passing through the plate heat exchanger, absorbing the heat from the liquid ammonia, which was on the left-hand side, shown with the blue color. And then as soon as it absorbs that heat, it evaporates, and then it gets in vapor form again into high temperature accumulator. So as you see right at the bottom of the high temperature accumulator, I have a bit of a liquid, but I cannot separate. It doesn't make sense to separate that small portion of the equipment and identify it as node. So here is your rule number 4, which is explaining the exception because it doesn't make sense from common sense point of view to separate that to an independent node because it's small, and as soon as it passes through the heat exchanger, again it comes back in vapor form. So I thought there would not be any benefit to separate that as a different node. So that's why node 4 will start from the expansion valve, and it will pass through the evaporators, come back to the high temperature accumulator. Then the top of the accumulator, which got the ammonia vapor, low pressure, low temperature, it is routed basically to the suction of the compressor, which that line is also considered as node number 4. So just wanted to mention that if you're a newly promoted manager stepping into higher responsibilities, or an early career engineer trying to build real confidence in HAZOP, you're absolutely in the right place. My whole mission is to take you from complexity to clarity, from feeling uncertain to feeling in control. Everything I share with you here is designed to help you understand HAZOP in a practical, structured, and simple way, the way I wish someone had taught me when I first started. This channel is your learning toolbox. If you ever need deeper clarification or want to talk about your specific challenges, you can book a free 15-minute consultation with me at no cost, no pressure, and no obligations. Just we'll be having a bit of a chat to clarify your questions, to help you move forward in a very quick manner. Thank you very much for watching this video, and I hope that this video will help you to get a decent handle of rule number 3 and rule number 4, and would be useful for all of you dear listeners. Thanks.